The Bombogenesis and Bomb Cyclone by Selena Scola, February 2024. According to NOAA.gov, bombogenesis is a meteorological term that refers to a specific type of cyclone that occurs in the latitudes between the tropics and polar regions, known as the mid-latitude. Meteorologists monitor the cyclone for signs of rapid intensification or low-pressure weather systems. The classification criteria for bombogenesis is based on a specific rate of decrease in central atmospheric pressure, measured in millibars within the system, and is indicative of a strengthening weather system. Classification criteria for a cyclone to become a bombogenesis weather event include a 17 to 24 millibar latitude dependent decrease in air pressure within 24 hours. In simpler terms, imagine getting a flat tire while driving at speeds between 60 and 100 miles per hour. As the cyclone strengthens, the pressure in the center drops as the air moves faster and is pulled upwards, leaving less air near the ground, creating a powerful bomb of severe weather conditions, including heavy precipitation, which can be in the form of rain or snow depending on the system's temperature profile and the time of year. The mechanisms driving bombogenesis involve a complex interplay of atmospheric conditions, including intense temperature differences between air masses strengthen the disturbance in the jet stream, forcing air to rise and creating the rapid development of a low-pressure system, thus starting the bombogenesis process. A strong jet stream can contribute to the development of bombogenesis by enhancing upper-level divergence above the low-pressure system, effectively pulling air out of the system and allowing it to intensify. Warm sea surface temperatures provide additional energy to the developing cyclone, aiding its rapid intensification. Bombogenesis is usually associated with nor'easters along the east coast of the United States due to cold air surging southward from Canada, combined with the warm ocean waters of the Gulf Stream. However, they are becoming more common in regions such as the Pacific coastlines of California, due to the extra weather brought by El Niño, combined with unusually high amounts of water vapor in the atmosphere, due to abnormally warm ocean waters in an ever-increasing warmer world due to changes in our global climate. Now that we have covered the formation process of the bombogenesis, let us explain the difference between a bombogenesis and a bomb cyclone. Process versus result. The main difference between the two terms is that bombogenesis describes the process of rapid intensification, while a bomb cyclone refers to the actual storm that results from this process. Scientific versus popular use. Meteorologists and atmospheric scientists have been using bombogenesis since the 1940s, and it is commonly used in conjunction with scientific terms to describe the process we describe above. Bomb cyclone is a term coined by a pair of MIT meteorologists in a 1980 research paper published in Monthly Weather Review. However, the term did not become popular until utilized by the media after a bomb cyclone bombarded the northeast United States in January 2018. In short, a bombogenesis is the rapid strengthening of a storm, and a bomb cyclone is the powerful storm that results from this process. Though both terms indicate weather events that can cause severe damage from high winds ranging from 60, 100 miles per hour, heavy snowfall, including blizzard conditions, coastal flooding, flash flooding, mud and rock slides, and extreme lightning events as the system bombs out. In March 2023 and February 2024, bomb cyclones formed along California's coast, boosting California's atmospheric river weather events, which we have covered weeks prior. The damages from these storms were catastrophic. In March 2023, a bomb cyclone developed off the coast of San Francisco when the atmospheric pressure dropped 24 millibars in 17 hours, producing the strongest March storm ever recorded in Bay Area history. Winds reached speeds of 90 miles per hour, knocking down at least 700 trees, killing 4 people, blocking major roadways and highways, and were blamed for the derailment of an Amtrak train carrying 55 passengers when it struck a downed tree on the track. The wind gusts also overturned a tractor-trailer rig on the Bay Bridge and knocked out windows in high-rise buildings, sending shattered glass onto the ground and people below. Tens of thousands of utility customers were without power. Evacuations were highly recommended for some areas after a mudslide caused road closures. The National Weather Service issued a flood advisory warning. I live in San Francisco and was here during both storms. the storm was as intense as described. If I remember correctly, it also hailed at the end of the storm and snowed to the north in the mountain regions. Unfortunately, these extreme weather events and violent storms might be the new normal for the Bay Area. Concluding questions for the audience are: what are the potential impacts of bomb cyclones on California's environment, infrastructure, and communities? Is research currently being conducted on the anomaly of bomb cyclones in California? If so, how will this improve forecasting and preparedness? Do bomb cyclones in California differ from those occurring in other parts of the world? Thanks for listening, and I look forward to reading your replies to the concluding questions.